Our next speaker is Jean-Yves Nief of CCIN2P3, and he is going to, his talk is titled From SRB to iRODS, 20 Years of Data Management at the Petabyte Scale.
Okay, thank you very much. So it's going to be a kind of a vintage talk made by a vintage guy, and we've wearing a vintage t-shirt from 10 years ago for the iRODS Tucson meeting in 2012 here. Okay. So I'm going to talk about usage of data management tools such as middlewares like SRB and then iRODS. I'm the head of the storage team at CCIN2P3. So CCIN2P3, what is it exactly? It's a computing center located in France. It's part of CNRS. CNRS is the National Center for Scientific Research. There are many institutes, arts and humanities, math, fundamental physics. And one of the institutes is IN2P3, which is an ugly acronym for National Institute for Nuclear Physics and Particle Physics. There are around 20 labs spread all around France, which are participating to national and international collaborations, mainly experiments at CERN, for example, which is rather close from Lyon. And part of that, there's a computing center, which is located in Lyon, where I'm working. We are providing computing resources for all these international collaborations. So basically, storage, computing, and also web services and all kind of stuff. The resources are open to both French scientists and also foreign scientists. Actually, I think there are more foreign users than French users are using our facility. We have 2 computing rooms in a couple of numbers, less than 2,000 square meters with 2,000 servers, physical servers, and 800 virtual machines. Who is using CCIN2P3? Well, a lot of experiments which are widespread everywhere, mainly in Europe, but also in the US, South America, and also, well, it's being used for experiments which can be in space, like satellite observation experiments. Why do we need data management middleware? Well, CCIN2P3 is participating to a lot of international collaborations, which means interactions with other computing centers and users which are spread worldwide. They are working on their local cluster in their university or even on their own laptop, for example. So we need to, first of all, transfer, share, and manage common sets of data. We need also to identify and give different roles to different users. And we are using heterogeneous technologies, operating system, storage system, hardware, protocols as well. And so we have to deal with that because not everybody is working in with the same tools. And we come from very far, actually, because in the 90s, and I do remember as a PhD student, the data transfer, for example, between CERN and CCIN2P3 was made with the van. And actually, sometimes I was filling the spreadsheet to transfer a certain amount of data, a certain amount of tapes, and it worked like that, and it worked pretty well. Even now, a couple of years ago, we were transferring data by plane from Namibia so in close to South Africa, in the middle of desert. So we had to do that by plane. There were no other means. But at the end of the 90s, network bandwidth was much better, was improving very quickly, and we started to do data transfer through the network. And so we started to build and to manage a system, homemade system, with a protocol based on TCP/IP, and with a local database and things like that. So it was homemade system. But you have to deal then with multiple homemade systems made for each single experiments, and that can't work forever. This was a problem. So this is why we needed a middleware. Some middleware are used by, for example, the LHC experiments at CERN have got their own middleware, but we needed also some middleware to manage all kinds of experiments. And this is why we were interested by a middleware called SRB, the Storage Resource Broker, which started in 1999, I guess. We had our first SRB installation at CCIN2P3 in 2002, and we put in production in 2003 SRB to make to be used for one CERN experiment, CMS, and also for another high energy physics experiment located in California, in Stanford, called Babar. And then from there, we had new users coming in 2005 with biology and astrophysics experiments. And we had our first iRODS installation in 2006. So we're beginning also contribution to the software development as well. And from there in 2006, in 2008, so 2 years later, we put our first group in production with iRODS. 2009, we had a high available iRODS. I will go to that a bit later. And 2010, we were still using SRB at the level of 2 petabytes, which was reached. And we did our first SRB to iRODS migration at that time. So as you can see, it's always a pretty long process because you cannot move to a different technology just like that, because there are many other pitfalls, well, because the users have already all their workflow implementation, so you cannot change all that in just a blink of an eye. So it needs quite some time. So only in 2012 we reached 2 petabytes in iRODS, and only in 2013, so 7 years after the first iRODS implementation was made, we phased out SRB. So we use SRB for quite some time. I didn't want to put things in a hurry. We were not in a rush, so we did it very smoothly. Well, at least as smooth as possible. So as for now, we reached 26 petabytes in 2022. With 27 zones and almost a bit less by 500 millions of files. So it's only a part of the data which are located in Lyon, which are managed by iRODS. We have around 140 petabytes of data. So it represents 20% of data managed by iRODS. So who is using iRODS or was using iRODS or SRB? So many experiments, in particular physics, nuclear physics, astroparticle and astrophysics. Currently, the further experiment that we have is located in Argentina, and they are really doing migration, well, data transfer from Argentina to Lyon. It's in high energy cosmic ray studies using iRODS. and they are also sharing data based on their simulation, which are computed in other computing center in Europe. But we are also using iRODS for biomedical studies and in biology. Especially, you can see a picture of a bat. We are recording that some researchers are recording bats sounds, the waves. So it's wave files that they are analyzing. And they, at the moment, they have 400 terabytes of data, but they want to go to reach 10 petabytes until the end of the decade, so which is quite a lot. So evolution of user needs. So we have to remotely share, manage data from widespread collaboration. And also we have the need to upload and download files on local sites. So a distant site, or at CCIN2P3 for data analysis through other means, because iRODS is really meant to be a data management system. We, for very high throughput data analysis, we use other means. So that in these systems, the data are in read-only mode, like some systems which are not used in high energy physics, like maybe you know them, XRUD, Dcache, and things like that. But it's only in read-only mode. And we have to manage workflows for distributed computing systems, resources. So the user's profile that we have developers who are providing applications, developing applications. So we are not developing applications, they are developing applications based hiding the iRODS usage to the end users. And we have also end users who are using the system directly. So we have usually skilled users who are used to Unix commands and doing scripting and things like that. So it's not a big deal for them. And iRODS is also being used indirectly through web interfaces and other stuff. So the way of interacting with iRODS is very, there are a lot of ways of doing so through commands, APIs, mainly Java and C, web application, and web dev, which is becoming more and more popular. So the main pitfall that we have at the moment is the lack of control of the amount of parallel connection that we are doing on the system. So basically, if someone from the outside who are, for example, downloading files, we can have hundreds of clients at the same time, so they can put a big stress on the system, and we have no control to try to throttle the amount of connections, because it's certain way it's kind of wide open system. Some users come from very far, so from using external disk, even recently. So there's a big step to go from external disk to using a computing center and being fully aware how to use a middleware like iRODS. Metadata, they have been there for a very long time in SRB, and then of course iRODS for almost 20 years. But it was seen like kind of a gizmo by some people. They didn't see the real interest of that. And usually, well, you have certainly seen that they are describing their data with using the collection names. So in the directory names and things like that, you have a whole story about the data. But mindset has changed a lot in the last couple of years, and users now, I was surprised, are asking for metadata, AVUs, which is, I think, a big major step forward, because for a lot of people, data management is about just moving data around, and that's not just like like that. And but as you can see, SRB and iRODS were really at the front edge and well advanced compared to some users' needs. Storage virtualization. So it is an help of course, handling widespread heterogeneous storage systems. But the danger, it makes life too easy. And I do remember even in the early 20s, year 2000, we had some Windows application for SRB where you could do drag and drop in INQ, if I remember well. So it was very easy for the end user to drag and drop data. So at some point, someone just drag and drop his C disk. Imagine that you have interfaced your storage system with a mass storage system. You're going to have a huge amount of small files onto your system. And that's really bad. So it's very nice, but it's very dangerous because people don't know what we're going to do. It can be very harmful for the system. This is why we were really pleased, and I was very enthusiastic with the idea of iRODS with a policy virtualization system. That's something very obvious for a system manager. However, for the end users, it's not very easy to, even now, to explain what it is. I think that's a major difficulty. And even to try to convince sometimes a system storage manager to go through that kind of system, because they're not really understanding easily this notion of policy virtualization. Federation capabilities, where we didn't use it that much. A little bit, we have some capability with on our campus. We are federating with other labs who are using iRODS at the national level. And also, I've got an example for Transatlantic Federation with California, where we did for a long time data transfer from one site to another in order to have the two catalogs synchronized and to have the data transferred automatically. So in very easy way. So our architecture, it's a high availability architecture since 2009. So we have the provider servers. We have several provider servers, 2 at the moment. Okay. With a DNS alias. So if one fails, it continues to work. Linked with Oracle database system, which is also highly available. Data servers, 4.5 petabytes, and it's linked also to our mass storage system as well. I'm not going into the detail. We can go up to 100 terabytes per day for filling the data. And it's not always the case, but it can happen. So iRODS is able to handle some heavy production. And migrations, we had across the time, through the time, a lot of migration going on. Operating system, we started from Solaris 8 on Spark to CentOS 7. That wasn't a big deal because the 2 tools, SRB and iRODS, are really able to adapt to any kind of operating system. Hardware also is not a big deal with the way to run on the fly data migration. However, we still have the issue, and you will have the same problem with any kind of protocols with a small file data transfer. That's something. Technology, SRB to iRODS was obviously a bit disruptive, and we made it step by step. iRODS version 3 to version 4 is still ongoing, and it's not always that easy because we need to adapt to our high availability system and the way we are installing things, because we have physical servers on which we install a lot of instances which are running at the same time. So no virtual machines, no containers. maybe we will have to think another way, but not yet. So the prospects, there's a lot of talk about fair data everywhere. We try to stay in the real world and try to do real things. We are struggling with our users to adopt a data management plan. And we are in a process of trying to make our data management plan machine actionable. So in a way, check the data, for example, the data policy which has been written in the data management plan is in agreement with what is really happening on the iRODS side, for example. And we are also working on long-term data archival using OARS standards and based on a library called RODA and iRODS and access modes. I think that for the near future, REST APIs are very important, web access as well. Authentication are certainly going to switch for some people to OpenID if it's going to be possible, and a mechanism to throttle incoming wide open connection is very important. So last but not the least, I wanted to thank my colleagues, because I'm not the only one who is working on the system. And also big thanks to the iRODS teams across the age, through the age. And so it's, we are very delighted with the iRODS usage.
All right. Any questions about any of that? Oh, we got one right here.
Hi there. So really interested to see how many connections you've got coming in for that's sustainable. Is that spread all over just the 2 servers you mentioned? Because you've got, yes, what, 27 zones. So is that across all of them, or?
So it's, when I say to this couple of millions of connections, it's through the 2 main servers, the providers, the ICATs. Yes.
And you mentioned 26 petabytes worth of data. Is that replicated, or is that just 1 copy?
Sorry, can you?
Is the 26 petabytes worth of data usable, i.e. replicated, or is it all 1 copy or a mix?
Some data are replicated, yes, elsewhere. But some of this data are only available on our side. But some of them, yes, are replicated within iRODS as well.
And you mentioned about the rate limiting. I think, was it last year or the year before at the UGM, Tony Edgin from Cyverse gave a talk on how they've been doing rate limiting using HA proxy. So I don't know if you're aware of that, but if not, might be worth having a look at.
I'm not aware of that. Okay, so for example, LHC experiments are using a Dcache system, which is developed by DESI in Germany, and they are using their own middleware. And the data, most of the data are still going to the mass storage system, which is based on handled by HPSS from IBM on our side, but on the other side, it's so mainly it's Dcache, and also we have some NFS services, NAS, based on EasyLearn and also CephFS.
All right, just one more.
Yeah, just a quick question. So on slide 11, you mentioned that you have like 27 instances of iRODS. It means that you have 27 ICAT servers, right?
Yes.
Yeah, and are you using some high availability setup for any of those? Like multiple ICATs for 1 zone?
Yes, that's, how can I go back? Okay. Okay, thanks. Here, we have at the moment 2 two providers.
Mhm.
On these two providers, you have 27 iRODS servers running.
Right. Okay.
So if one fails, there's still a possibility to use the other one, because the end users, well, the applications which are running, connecting to iRODS are using the CC iRODS alias.
Right. So it has
So-
like multiple A records there.
Yes.
And if you want to take down one of the servers, you have to manually adjust the record, right? We have some automated process for that.
For that, I remove the server from the DNS alias.
Right. Mhm.
And
Yeah.
that's it.
Oh, okay. Thank you.
All right. Let's thanks, Jean-Yves.